we'll skip all of that. We go first page, only the first page. We're not going to do the um exercise from this exercise, like from this F, but we will just talk about the meaning of limit. Okay, so what means by limit? I think the book is not in a like reasonable order to directly jump to lim and without teaching you what is lim. So I always put this exercise in the front to go through that. But like I see the schedule plan, we don't do exercise F. That's the problem. So I just go through very briefly talk about what is limit means. Okay, so what is limit? Okay, limit means we consider the function of limit fx to be the value fx, or let's say fx is just y. So y approaches as x approaches a given value. X approaches a given value. Okay, so that's the meaning of limit. Okay, that's the meaning of limit. So lim x approach to a of fx equals to p. Okay, so just look at this expression. I know it's something you haven't learned, but that means x approaches to a, fx, like also I change that to y will be easier. Y approaches to p. Okay, trying to learn that now because you will learn this anyway in year 12, and it's very important concept. Because it's very important concept. So lim x approaching of fx means for function fx, when x approaching to the a value, y value will approach to p. So it is important to understand that it's possible to get as close as desired to px when x approaches to a. So it means I'm just getting towards to it, very, 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 very close to that value, a value, but I'm not actually step onto that. I'm not actually taking that value. I'm just going closer and closer to that value. Okay, so for for a function fx, a limit exists at this point a if the left hand side and right hand side limit exist and equal. Okay. So we sometimes limit does not exist. I will like in a minute I will show you examples why limit exists, why limit does not exist. But the definition to make limit exist means when you approach from the left hand side of the graph and when you approach to the right hand side from that graph, you approach to the same value. Okay, you approach to something and approach to the same value. So fx may or may not define at x equals a. So okay, I can't really talk about that with you now. Um, just look at the graph. Okay, just look at the graph. I want to talk about whether limit x approaching to 0 fx exists or not. Okay, so I want to talk about when x approaches to 0, what's fx approaching to? Okay, what is the y value? So basically means when x approaches to 0, what y value approach to for this function? Okay, sometimes it may approach to different things. Okay, let's look at the first one. Okay, 0 is here. So which point I'm looking at? I'm looking at x equals to 0. So what I want to do is I want to draw a vertical line at that point. Okay, for all of these graphs, I'm talking about when x equals to 0, what y value approaching to. So the first thing I will do is I will draw a line at x equals to 0 for all of these graphs. Okay, it's just easier for me to think about. I'm talking about the value on this line. I'm talking about the value. Okay, I'm talking about these values. For this one, it's a bit hard. I will just draw a little bit dash lines here to make it clear. Okay. What we look at, so how do we think about limit? What we want to talk about for limit. The limit is what y value approach to as x value getting closer and closer and closer to 0. Okay, let's think about that as a walking path. Okay? People can walk on this function. And then this is a wall. You have a person on the left and another person on the right. Okay? They walk towards the wall. Towards it. Like this is already blocked. Like x equals to is blocked. You can't really stand onto the wall, but you can get as close as possible to the wall. You can just go closer and closer and closer. Just think about this is like different levels of like a supermarket. Think about it that way. So when you walk on this path and then get really close to the wall, which level you at? When you walk on this path? One, level one, right? How about the other person? Walk to this side. One as well. Okay? Yeah, that's y equals to 1. Okay, that's y equals to 1. This function is y equals to 1. Then I walk on the left. towards the wall and they approach to the same level. Same, like just separated by the wall, but they walk towards each other. So this means limit exists at x equals to 0. So limit exists at x equals to, how I will write it is lim x approaching 0 from the left hand side. Okay, the left hand side person walk towards the wall on function fx, that equals to level 1. Okay, I'm approaching to level 1. And lim x approaching to 0 from the right hand side. I'm walking on the right hand side for the function fx, and I'm approaching to level 1 as well. Okay, in this case, left hand side limit and right hand side limit exist and they are equal. So the conclusion I can make is lim x approaching to 0 of fx does exist and it is 1. Okay, so y value is approaching to 1 when x approaches 1. Okay, the next graph will make it really clear. Okay, the next graph will make it really clear. If you see the color, like the color I have here, like the green thing is the wall, okay? So there's a path on the left in the supermarket. On the red, there's the red one. And there was a path on the right hand side, which is the blue one. Think about two persons walk towards the wall. The left hand side person will approach into which level? Think about the red path. You walk on the red path. -1, right? Lim x approaching to 0 of the left hand side person walk on the graph of fx. I'm approaching to level -1 because that's where you can end up with. That's the last one you can end up with. Okay, you're approaching to that because level 1 is on that point, but I go towards that point. Okay, closer and closer and closer to level -1. How about right hand side? If someone walk on that blue path from the right hand side, what y value approaching to? 0. Okay, left hand side and right hand side don't have limit, but they are not the same value. So the conclusion I can make is because lim x approaching to left of fx does not equals to lim x approaching to 0 from the right of fx. So limit x approaching to 0 of fx does not exist. From the left, from the right. 0 negative, top negative is moving from the left hand side. I see the left hand side of 0. And then blue is the right hand side, so it's the positive side. I go from the positive side of 0. So right hand side of the 0 and move towards. For the 0, not for the function. It says on top of 0. It's like 0 negative and 0 positive. So left hand side of 0 and right hand side of 0. Alright, that's the second one I want to talk about. And if we think about the third one. Right. Again, the red is the wall, and we have left hand side and right hand side path. If someone walk on the left hand side, what will happen? If I'm trying to walk towards the wall, what will happen? Infinity. Okay? Lim x approaching to 0 from the negative side of fx is approaching to infinity. I'm not going to write equals to infinity. It's towards infinity. I'm not going to write equals to infinity. Infinity is not a number. Okay? Infinity is not a number. So it's not equal to. Okay, I don't have something equal to infinity. Infinity is just expression, means like infinity large, but it's not a number. So how about work on the right hand side? Same. There's no lim because left hand side lim and right hand side lim does not exist. There's no value. I need a value, but there's no value for left lim and right lim. So no value for left and right lim. Left hand side and right hand side lim. So limit does not exist. So even though both sides is approaching to infinity, but that's not a point. That's not a value. So limit does not exist in this case. All right. Last one. Okay, last one. I'm not sure if you can see that clear in your graph. There is an open circle here. Can you see that? Yeah, there's an open circle here. Set as 0, 1. That's an open circle. Okay, so it's a linear and then an open circle here. So let's think that's the wall. All right. Okay, someone work on the left. Which level you approach to in this case? Of fx. Well, is that really matter when you have an open circle at 0? Like this point is open circle of 0, 1. Is that really a problem? Yes, correct. You're not necessarily equal, like when x equals 0, y equals 1, not necessarily defined at that point. It's not, yeah, it's approaching. Approaching is get closer to. I'm not step on the hole, like I'm getting towards and towards and towards to the hole. So the further I move to the wall, the more closer to level 1. Okay, so this is still equals to 1. Doesn't matter whether you have the open circle or you don't have the open circle there. It doesn't matter. I'm approaching to that value. How about this one? Right hand side. Which level I'm approaching to? Same. So limit does exist in this case. Both sides equals to each other, so the limit equals to 1. So this open circle, which is talking about this sentence here, fx may or may not define at x equals to a. So I can have a point at a, or I can have an open circle at x equals to a. It doesn't matter. If I'm talking about limit, I don't really care what happens on that point exactly. I care about more what is approaching to, which value you get closer to. Okay, so that's limit. And if you can go to page 3, I just want to quickly talk about without the graph, how we can evaluate limit. Okay, without the graph, how we can evaluate limit. You're not going to sketch the graph all the time. Okay, boys, I think you may need to listen to this one. Okay, without looking at your screen. Okay, so what happened here is I want to evaluate limit, but I don't want to see the graph. I don't want to always see, okay, what happens left hand side, what happens right hand side. Can I just look at the limit expression to get a value? So there's one useful definition here is the limit for the constant function, the limit of the function is always equal to the constant itself. Okay, so what that means, lim x approaching to, doesn't matter, approaching to something, over constant 4. That always equals to 4. Doesn't matter what value of a you take, because everywhere the y value is 4, and it's always approaching to 4. Okay, it doesn't really matter what's the like approaching, what x approaching to. So that's always the constant itself. So knowing that, what's the limit of x approaching to of 10? 10. Okay, I don't care what x approaching to, y value is constant, it's always 10. So you're always approaching to the level like 10. All right, so to evaluate limit, there's 2 rules you need to remember. One rule is, can I substitute directly? Can I sub the x approaching to 0, say the second one, x approaching to 0. Can I sub x equals to 0 directly into the function? If I can, sub it. Okay, that's the first rule. Second rule, if I can't sub the value into the function, for example, this one. Okay, can anyone tell me why I can't sub it in? Denominator is 0, okay, in that case. So I can't sub in. If I can't sub it in, do some simplifications, cancellations, factorize, cancel, and then sub in. Okay, so do something to the function to simplify it first, and then sub in. So anyway, I want to sub that value into the function. That's all I want. So all what I need. Okay, so for part B, if I can sub x, can I sub x equals to 0? Is there any problem? No. Okay, just sub 0 in. That's 2 times 5, which is 10. Done. If I can sub in directly. If I can't, do something first and then sub in. Yes. Next one, can I sub in? Yes. So that just directly equals to 4 plus 5 plus 14 over negative 4, and that is negative 19 on 4. Okay. So if I can sub in directly. If I can't, okay, next one is I can't. Where is it? Okay, next one I can't. But what I can do? Yeah, so in this case, you still maintain this expression here because you still have that. You haven't sub in. If you sub in, you can get rid of the lim. If you haven't sub in, you need to keep that with your expression. So what I'll have is 2 that over that. I can get rid of the x plus 3 on the denominator and numerator, both. And now can I sub in? Yes. No denominator now, I can sub that in, which is just 0. Okay, next one. Can I sub that in? It's not going to be always equal to 0. Okay, it's not always like that's just coincidence. Like equal to 0. It's not always an x. You can see the next one. What happens? For the next one is we need to factorize that. So we have x minus 2 and x plus 3 on top. So factorize that first, and I can cancel those two. Yeah, but that's not 0. Can you see that? That's not 0. So can I sub that in now? Yes. So 2 plus 3, which is 5. So the limit is 5 in this case. Okay. Like this whole expression equals to 5. Oh, you don't need to rewrite, just equal. It's like an expression, just keep like that expression equals to that expression equals to that. Can anyone tell me the quickest way to factorize that one? The dots. Okay. You can expand and then just do something, but I can use dots. Difference of perfect square. A squared minus b squared equals to a plus b and a minus b. That's b squared. So that's a squared minus b squared. That's a plus b times a minus b of 2x. And can you see here, the 3 and minus 3 can get cancelled? And the 2x and 2x, they can just, yeah. Surprise. And I only left expression what is possible to sub 0 in now is the 6 plus 2x. And now I can sub x equals to 0, which equals to 6. Yeah. So that's how to evaluate limit. Basically, I just want to give you a general idea on what is limit and how to evaluate limit. If you sketch all of this graph and look at the left-hand side and right-hand side, it will be the same thing. Now just go, I'm not going to talk about all of these. That's all pure definitions. Go to page 5. Now let's talk about A, derivative. And I'll give you a bit better understanding here. Let's have a think. Okay, look at example 1. Let's evaluate those limits first. Okay, what's limit h approaching to 0 of 3? But h will be the same as x. Like it's just a variable. So what's the limit of a constant? The constant, so what is that? 3. Okay. That's that. Maybe I ran it like not that nice. That's this. Yeah, because 3 is like the function. So the constant 3, the limit of h approaching to 0, 3 is 3. All right, next one, very challenging. Okay, that's the function. 3x is the function. But I'm not saying lim x approaching to 0. I said h approaching to 0. What do you think this will be? 3x, good. There's nowhere to substitute h equals to 0. So we treat 3x as a constant. So it's just the 3x itself. There's nowhere to sub h equals to 0. Where do you want to sub it? There's nowhere to sub it. All right, next one. What do you think this will be? Yep. You just sub h equals to 0. H equals to 0. That's it. Yeah, x not affected by h, so I only care about the h terms. Okay, what happened to this one? 0 denominator. I just tell you, if you can't sub it, you need to simplify it. Yeah? And there's no h anymore, so that just keeps at that. When you cancel it like that. When you simplify it. Okay? Okay? Okay, all I talk about is just the introduction of derivatives. Like you need to understand that, and now I can talk about derivatives. Anyone remember what is derivative? That's not derivative. That's not at all. Okay. No. No, derivative is, I talked about what's the definition of derivative last lesson, just yesterday. Exercise B. Oh, no one remembers? Derivative is the gradient of what? It's the instantaneous rate of change, and it's the gradient of the not the we're not talking about tangent. Okay. So derivative in general, not only talk about distance, velocity, and acceleration. Yeah, you can't. It's right. It's right. Okay, let's write this down on the top of this page. You need to know what is derivative, guys. Guys, it's class time. Okay, what is derivative? You need to know the definition for derivatives. So derivative is talk about the instantaneous rate of change, and it's the gradient of the tangent. Okay, so let's write that down. Derivative equals to is like the instantaneous rate of change, and that equals to the gradient of the derivative, gradient of the tangent at that point. Rate of change. That's the instantaneous rate of change, and it is the, well, when we say derivative, like some students, I realize like they know how to do derivatives. They can find derivatives, but they don't know what that means. They don't know why we find it. So it's actually talk about at that instant, what's the particle's direction of motion, or say what is the gradient of the tangent, so that red line, the gradient of that red line. Okay, yesterday when I talk about a method, I say I can approximate the instantaneous rate of change. There are two methods. One is the graphical one. I draw the tangent and I root 2 points from the tangent and then find the gradient. What's the other method? Well, you know the function. Yeah, I know the other one. Okay, so yep. Okay, if I have the point A, comma FA, and I want to find the, everyone just be quiet, thank you. I want to find the gradient, like the gradient of this red line, but I can't really find it like directly because there's no other point. So the method I use is to select a point really close to this point A. Okay, really close to this point A on the original fx graph. So this pink point will that point will be A plus H. FA plus H. And if I draw this line, like if I connect those two lines, these 2 points, I get this red line. The closer those 2 points is, the more accurate this green line, like gradient will be closer to the red graph. So if I choose the point, like say the H is 0.00000001, then the red line's gradient will be almost the same as the red line's gradient. Okay, so I'm actually using the red line's gradient to estimate the red line's gradient. So what is the green line's gradient? Like what's the line, this line's gradient, the green one? So it's FA plus H minus FA over, well, over y x2 minus x1, which is this one. Yeah. I will start from there and then add a little bit things on, and then that will be the accurate answer. So now, what I want to do here is, I will just, that's the H. Okay, listen, this is the green line's gradient, right? And I said the gradient of the green line can be really close to the gradient of the red line if h is what? No, it can't be equal, approaching to zero. So what I'll do now, like after we learn the lim, we will set lim h approaching to zero of that function. So I do h can be anything. When I say this function h can be anything, and now I don't want h to be large. I want h to be as small as possible. So I make h approaching to zero. Now this green line gradient will be like approaching to this red line gradient. Okay, or approaching to that. So if I evaluate that in this way, the red line and green line will have the same gradient when h approaches to zero. Okay, when h gets closer to zero, the red line is getting very similar value to the gradient of the red line. So in this case, I can write that equals to f dash a. F dash means the gradient function. Okay, f dash is the gradient function. So it's the gradient at point A can be evaluated by this method. Okay, can be evaluated by this method. Okay, so let's highlight this one. Okay, f dash a. What's f dash a? Is the derivative. Okay, derivative of f at x equals a. Okay, it's the derivative of f at x equals a. Also, it's the gradient of the tangent at x equals a. Is the gradient of the tangent on fx at x equals a. We keep talking about the same thing. It's the gradient of the tangent. Okay, on the curve fx at x equals a. Okay, and there's another one means it's the instantaneous gradient at x equals a. So it's the instantaneous rate of change at x equals a. Now, yeah, using this, I can only find the gradient, like it's a value. Like after evaluate this one, let's write this down. Like students always confused about that. After I calculate, I do all the calculations, I can get a value out from this. Okay, it's just a value. It's the value, it's the gradient of the curve at x equals a. So it's a value like n is 4 or 5 or a third. It's a value. But I can make it generalized. I don't want to just talk about one point. I want to think about every other point what will happen. So highlight this one. We have something called first principle. This is the first definition we learn, like first rule we learn basically. What we have done is change all the a to x. Okay, a is a particular point, but now I don't want a particular point. I want it made in general, like it's at any point in this on this curve. Okay, so make a become x is basically any point on this curve. So what I would say is like something like that. This point is not a comma f a now. Like it's any general point on this curve is x comma fx. Because x comma fx is not a comma f now. It's like in general, like x can be any value. I can sub x equals to any value into this function. Okay, so after you calculate this, after the calculation, this is a function. This is a gradient function. Okay, it's not a value. It's not 4, it's not 5. It's a gradient function. It could be 2x plus 1. It could be 2x plus 1. It could be x squared. It's a function. But if you ask me like why, like how we can evaluate, we just sub value in. We just sub x equals to 2 in to find the gradient x equals to 2. Sub x equals to 1 in to find what x equals to 1. So those two things are highlighted look basically exactly the same, except this is a value here. It's like 1, 2, 3, 4 here for a. But this one is a more general case. It's just an x here. So you will get a value for the first one, but you will get an equation for the second one. Okay, so this is first principle. Okay, this is the first principle. First principles help you to work out the gradient function. one example. If you can go, well, let's not talk about example 2 yet, it's a long one. Let's just have a look at page 6, example 3. I want to use first principle to work out the gradient function. Okay, I want to find what f dash x means. F dash x is the gradient function. What is the gradient of f(x) of any value x? Okay, so it's a gradient function. Okay, you will definitely have questions on first principle for this test. Definitely. Okay, so you will have first principle. You need to know how to use first principle to work out f dash x. So when you see those two words, first principles, the first thing you write is this formula. F dash x equals to lim h approaching to 0 is the second one highlight for you. X fx plus h minus fx over h. Well, you don't need to think about anything. That's the first thing, right? That's first principle. What is first principle? This formula is first principle. And now using different functions, different rules of fx to sub things in. Yes? Yes. Because h is, we select the value next to the value I want to talk about, and this h always needs to be very small. Like x is just like any number. Like x is any number. So in general, it's a general case. Like I'm talking about the gradient of any point on the curve. Okay. So now I will use. Okay. What is fx? Your fx is 3 minus x cubed. Type that in. But what is your x plus h? Anyone tell me what is fx plus h? What's that? X cubed plus h? Correct. Yeah, so we replace x by x plus h in the bracket, and then we just replace it, like using the super rule, like using the rule given to you, and then put things in. Just stop that in. So therefore that becomes lim h approaching to 0 of 3 minus x plus h cubed minus 3 minus x cubed and over h. Okay, now I will check. Can I solve h equals to 0? No. Why? Okay, denominator 0. So it's not good. It's not good to substitute. So I need to expand everything and simplify it and then get rid of the h and then substitute. Okay, so I can't substitute. I can't just leave it there. I need to do something to make it possible to be substituted. Okay, cube, x plus h cube. How to expand that? Not squared, it's cube. I just directly expand it. 3 x h squared. And then, correct. Minus 3 plus x cubed. Where's my nose? It's here. Minus h cubed minus 3 plus x cubed over h. Alright, what I can cancel from the numerator? And here those x cubed can be cancelled. What else? 3, where's my 3? That's 3 and that's 3 can be cancelled. What else? I can divide h for all of them, that's right. I can divide h for all of them. That's a minus 3x squared minus 3xh minus h squared. Yeah, I can sum h equals to 0 now. What has left? Yeah. So the f dash x equals to minus 3x squared. Oh, like I'm just showing you how to use like first principle. All the rules, I know you guys know the rules, but all the rules that come from first principle. We will learn the shortcut as well, but this is just something. It's just something tell you why it's like that and how these things like come from. But you just need to know first principle. Yes, first principle. You need to know how to. They won't ask you ridiculous questions like quadratic or something. They're most likely to ask you quadratic or cubic. That's the highest power you can get. They can ask you maybe 1/x, like the like hyperbola function. Like, but that's it. That's the basic functions they ask you. Yes. No. Okay. So we will learn the shortcut in next exercise, but it's important to know why it's like that. Like I want to tell you where's that rule come from. Everything's come from first principle, and that's the logic we use to find instantaneous rate of change. All right. So after I got this one, after I have that, this is my gradient function. If I want to find x equals to 1, what is the what's the instantaneous rate of change? I will just say f dash 1 equals to minus 3. So the instantaneous rate of change at x equals to 1 equals to negative 3. Okay, equals to negative 3. That's basically what is first principle and what that means. Okay, so you get that? Yeah? Yes. Okay, kind of. So you can do some exercise to see how it works for you in exercise A, and, and then we will do the shortcut like on Monday. Next shortcut on Monday. And remember what you need to do. You need to do all the exercise from exercise A to exercise B in chapter 16, and Monday I'll check your work. Okay? Monday I'll check your work. Okay. You can use the quick method like when the question doesn't say first using first principle, but there will be questions particularly ask you, you need to show first principle. Correct. Unless they ask you to do so, you can all use the quick method. There will be a quick one, like it's really quick. I know why you hate this one, but you just need to know this and learn this.